Exercise 2, Coordinate Geometry, Distance Formula. In part 1, calculate the distance between the following pairs of points, as indicated there. Right, now in part 2, find the area of the right-angled triangle whose coordinates are A, 4, 3, B, 3, -1, and C, -1, 0. Right, now here are the answers to question 1, part 1. The answer to this one was 13. The answer to this one was 4√2. The answer to this one was Q outside of square root of 4p squared plus 1. And the answer to this one was p squared plus 1. Okay, and the answer to this one was 8.5 units. 8.5 units squared, sorry. Right, now here are the solutions. Okay, I'll make this one x1, y1, x2, y2. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance is equal to the square root of 11 minus -1 squared plus 7 take away 2 squared, which gives 144 plus 25, which is the square root of 169, which is 13 units exactly. Okay, number 2. Okay, we'll do this. It's x1, y1, x2, y2. Distance equals square root of x2 minus x1 squared plus y2 minus y1 all squared. So the distance is equal to, this will be equal to 3 take away -1 squared plus 1 take away -3 all squared, and it's going to be 16 plus 16, which is the square root of 32, and of course that's equal to the square root of 16 times 2, which equals 4√2 units. Okay, here comes an algebraic one. Here's our x1, y1, and our x2, y2. Doing it this way, you're just avoiding making an error when you're reading it. So that's x2 minus x1 all squared plus y2 minus y1 all squared. Right, now d equals square root of x2, which is p plus 2pq, take away p all squared plus 2q minus q all squared, and that gives me 2pq all squared plus q squared, which gives me the square root of 4p squared q squared plus q squared. I have a common factor of q squared, which I can take out outside the square root sign, and I'm left with 4p squared plus 1. Alright, 0, 1 and 2p squared. Okay, so our x1, y1, our x2, y2, our distance formula. Because if you keep on writing all this out each time, you'll certainly remember it. So it's going to be, I'll do it this way, x1 minus x2 for change. All squared. Okay, now we put that in. So that'll be 0 minus 2p all squared plus 1 minus p squared all squared, which gives me, that becomes 4p squared plus 1 minus 2p squared plus p to the fourth. Now note, this is a perfect square, so we add this one to this one, we get the result of 1 plus 2p squared plus p to the fourth, which of course is the square root of 1 plus p squared all squared, so you get the result of 1 plus p squared, or p squared plus 1. Find the area of the right angled triangle whose coordinates are 4, 3, 3, negative 1 and minus 1, 0. Now if we carefully plot these points, making sure the scale on both axes is the same, it'll save us a bit of time. So let's get A first. A is 0.43. You don't have to be deadly accurate, but just fairly accurate. And then you've got B, which is 3, negative 1 down here. And then you've got C over here. It's this one. See, now you can actually, when you draw that up, you can actually see where the right angle would be. Otherwise, you need to calculate each distance, which should be a bit painful, and just discard the hypotenuse, because you need these two sides to work out the area. Right, now, I know you know the formula, so I'll just write it all in. So AB is equal to square root of, that's 4 take away 3 all squared, plus 3 take away negative 1 all squared, and that's going to give me square root of 1 plus 16, which is the square root of 17. BC is going to be equal to 3 take away negative 1 all squared plus negative 1 take away 0 all squared, and that again is going to give me the square root of 17, which we would expect something like that because we know we're going to get a rational number. So the area is equal to a half the base root 17 times the height root 17, which is 17 over 2, which is 8.5 units squared as your final result. Again, what you could have done, you could have actually did it the other way I showed you, where you just draw up the various, this rectangle here, and calculated it out. But in this case, I think it's a bit slower. I think this is faster because it's the right angle triangle. Quite easy to work out those two distances.